Hello and welcome students to this another video lesson for grade 12th mathematics. And today we'll be discussing the homogeneous differential equations, the very next concept after discussing the variable separable method in our previous session. So before moving to our mainstream concept of homogeneous differential equations, first of all, we need to understand that what basically a homogeneous function is. And after that, we can proceed to our the main topic of today's session, that is homogeneous differential equations. So basically, we often come across to some functions, as you can see it over here. Two different functions are mentioned, f of x and y and f of g of x and y. So there is an interesting property regarding such type of functions. Okay, so let's pass these functions through a test to know the property that these functions possess. Okay, so substitute kx in the place of x and substitute ky in the place of y. So after that, what you can observe that the function becomes like that, and where k is constant. So what we can observe that in both the cases, the constant k with non-negative integral power can be taken common, okay, without disturbing the expressions. So two functions we are getting over here after taking k as common without disturbing the expression. So such type of functions are called as homogeneous functions, okay, in this form. So here, the function that you can see, f of x comma y, is of degree 2, okay? And the function g of x comma y is of degree 0, right? Where k is the constant. So any homogeneous function can be expressed as shown over there, as you can see on your screens, where n is the degree of the homogeneous function, right? So for example, let us see if we can consider that the first function, we can represent this function as shown over here. Uh, so we can further simplify this, and we can write like this. So this function can be further simplified and written like this. So this is the homogeneous function now, which is having a degree 2. Okay. So similarly, this function g of x comma y, which is given as y square by x square minus xy, can be also represented as in this form. So after simplifying this and rearranging the variables, let's see what we are getting over here. So y raised to the power 0 into g1 of x by y. So here you can see that 0 is the degree of this function g of x comma y, right? And in the first case, we are having degree 2. So now we define the homogeneous differential equations after getting an idea about the homogeneous functions. As you can see, two functions on your screen. So one is f of x comma y is equals to x raised to the power n g of y by x, and second type of function, homogeneous function, is f of x comma y is equals to y raised to the power n into h of x by y. Okay, so after that we can define that what basically a differential equation is. So a differential equation in of the form of dy by dx is equals to f of x comma y is said to be homogeneous if f of x comma y is a homogeneous function of degree 0. You have to keep in mind that degree should be 0 of that particular homogeneous equation, homogeneous function, right? So now let's take an example to understand the better of it, that what we actually have to learn about homogeneous differential equations. So consider a homogeneous differential equation of degree 0, as you can see it over here, and substitute the value of y as vx. Okay, so on differentiating this on both the sides, what you will get, dy by dx, okay, is equals to v by u into v rule. What we are getting, v plus x into dy by dx. By product rule, you will get this. Now what we can write over here, we can substitute the value. So what we are getting, differential equation in this form can be solved now with the help of a variable separable method that we discussed already in our previous class. Okay, so we got v plus x into dy by dv by dx is equals to h into v. So now we have to rearrange this equation by bringing the function of x on one side and bringing the function of together of v on the one side. So now we can see that the variables have been separated, and now we can perform the integration easily after doing variable separable method. So after simplification and integration, what you will get over here, so now after integration, you can again replace the value of v as y by x. Okay, so for homogeneous function, dy by dx is equals to y to the power 0 into h into x by y. Okay, so this was the first case in which the differential equation was given as dy by dx is equals to x raised to the power 0 into h of y by x. So in that case, you have to substitute the value of y as v into x, and after substituting, you have to just differentiate and put the value of that whatever you are getting over there in order to get some differential equation, and then you have to apply the method of variable separable method, and further you can perform the integration to get the final result, right? Then if the equation is of the form of dy by dx is equals to y raised to the power 0 into h of x by y, so in that case you have to substitute, okay, x is equals to v into y. Okay, so now let's solve this given differential equation. That is dy by dx is given as like this. So first of all, what we have to find that whether this is a homogeneous differential equation or not. So in that case, we have to convert this given equation, differential equation, into the homogeneous differential equation. For that, so what we can do, we can convert this equation by taking common, as we have discussed in previous slide, that after taking common over there x square, you will get this will be cancelled out, and we can see that this differential equation can be further simplified into this form, that is minus x raised to the power 0 into h of y by x, which is of a form of homogeneous differential equation. Okay, now here you can see that we can substitute now the value of y is equals to vx. Okay, now differentiating this on both the sides, we will get dy by dx is equals to v plus x into dv by dx. Now substitute the value of v plus x dv by dx, so we can get over here, now rearranging the equation by bringing the functions of v on the left hand side and the functions of x on the other side as shown over here. Now, after performing the variable separable method, you can easily perform the integration part. So now separating the variables, you will get something like this. That is the equation. Now you got the equation variable separable form, and you can further simplify the equation as shown over here. Okay, so finally integrating now with the given respective functions on both the sides. So after integration, what you will get over here, that is mentioned, highlighted over there. And after further simplifying, you will get this function. Further calculations are can be seen over here, that what we can do. And further simplification, 2v by v plus 1 whole square plus log of mod of v plus 1 into x is equals to log c. Okay, and again we can further simplify this, substituting the value of v is equals to y by x over here. So at this point you have to substitute the value of v, and again we can further simplify to get the final result and final solution of such a homogeneous differential equation. Okay, so solve it further to get the solution of this equation. So after performing few steps, you will get the final solution. Then you can apply the log properties also, and this will be our final step. So to get the solution as 2xy x square y upon x into x plus y whole square plus log of x plus y divided by c mod of log plus log of mod of x by x plus y by c, that will be equal to 0. So this is the final solution of the given differential equation. Okay, so whatever the differential equation is given to you, first you have to check whether that differential equation is of the form of a homogeneous differential equation or not. So if it is of the form, then you can further apply the substitution rule. Two rules are there that we discussed, okay, over here. That is the first one is if the equation is of the form of dy by dx, then in that case you have to apply y is equals to vx. And if the equation is of the form of dy by dx is equals to y raised to the power 0 h of x by y over here, you can see. So in this case, you have to substitute the value of x as vy, and then further you have to perform the differentiation and substituting the value over there. And further you can perform the variable separable method to get the final result after integration. So that's all for this session regarding homogeneous differential equations, and hopefully you understood the concepts, and we'll discuss some more questions in our coming Zoom sessions regarding this topic. Okay, in our coming Zoom session. That's all for this session from my side. Till then, you have to practice and go through this video class for easy understanding and practice some questions on your own. Okay, that's all. Assalamu alaikum to all of you.